do a talk tonight for you. It will be very simple because my language skills are not so good, and I will take it very simple for me. And I saw the other presentation. They were very good, and they also presented themselves. And I thought I would do this thing also. So my talk is a little bit shorter about the Axoloti, okay? And the Axoloti would be very low level, like tutorial, okay? I will explain a little bit what the Axoloti is, also the software, the interface, and how to do very simple patches on the Axoloti, okay? I know for the main audience it would be very not so interesting, but perhaps for someone who is new in this thing, it could be a little bit more interesting. Okay, when I go into this thing with the vector, or in the strange world of vector and video synthesis, and with these strange guys also, I got to my YouTube channel today in the morning, and I saw that's what's the first thing I does in the audio world, and it's not so far away. I thought, oh, it's 10 years I do this, 15 years, but in reality, I began in 2012 to do this. With my friends, they invited me to a workshop for circuit bending, audio workshop. And this was my first thing I've done. It's a little bit louder. If we don't want the noise. It's this. Okay. Okay, you know, I think the Atari Punk console. We had the kit and we made this thing, and it was so fucking crazy. And I thought, okay, with my friends, this is Hannes Pasqualini, perhaps someone knows him in the modular scene, he's Paper Noise, he makes a lot of panels for modular synthesizers like mutable instruments and so on, and another guy. We thought to make a little this secret media lab, okay? This was a very big community of 3 people, and we thought to make these workshops on circuit bending and so on, and making like a circus and this DIY work, and this was very nice also for me because I have no idea about circuit boards and electronics. I'm a nurse or a male nurse and I know I never studied these things. Okay, and we made this, and we had different workshops and also performances. And but I came from the video maker world because this was my passion to make videos. And I thought, oh, this audio thing, I not really know it about it. Why? What I can do in the video world with circuit bending or so on. And I searched a little bit on the internet and so on, and the main things I found was a blog like Video Circuits, this strange thing, and also the internet site from Karl Klomp that made it a really nice circuit band video mixer. Okay, and the first thing I made was this thing. Okay, a dirty video mixer. And I thought it's what that's, I think everybody here has made one, I think. And for the glitchy stuff, it's very nice. And I made this one. And here, this was my first performance. And you know the lines, okay? That's the first step. You see the lines. And I began to work also with Arduino and other stuff to try to make some glitchy videos and so on, and Arduino shields and so on. Another thing was I began to make these devices, video mixers or video effects, and I see I could bend it. This is one example. Okay, little one. Okay, and I like now doing this DIY stuff and take something and put it in a box and, huh? Yes, because for the panel it was simpler to cut out a carbon box, and the other was a wine box from local wine. Okay. And this glitchy thing was very my favorite interest in these years. And also like this, this mini CRT and so on, all this hacking within TV, and I began to go to buy these old little TVs that I find on €5 and so on, and I have a lot now, this old, really nice stuff. Okay, that's another project I have to finish, but okay, that's always a problem. I have very much project that I begin and never finish. Okay, this was a motorized video. How we called it? Kaleidoscope. And okay, and also here I learned a little bit about Arduino motors and these things. Okay. Oh, yes. And there's also a video out that you don't see now. Okay. And here, this is a video synthesizer made with Arduino. I could not remember what I did here. I couldn't remake it. Okay. Audio reactive and so on. Okay. And then come this, and like others, I got on the forum of Wiggler, and so did both of Lars, that modified the Vectrex, and I saw the first one, this rescanning thing with the plugin from Quartz Composer. Before I saw this, and okay, I saw this and they were very fantastic. Then I downloaded the tutorial from Andrew, and I bought a Vectrex and I modified it. And the first thing I'm not was able or aware about oscillographics, glitches, and this thing. I was only interested in the raster scanning thing, and it's not so good. Vectrex has not the bandwidth or to do the extra vector. But with some tweaking, you can hide this thing, and okay, this was my first thing with the Vectrex. My thing, it was always a little bit, therefore I bought the modular synthesizer. I don't want to use the computer for performances. That's what's the basic. Also, if the Axoloti, it's a kind of computer, I thought, okay, I want something what is not a computer to do oscillographics. And this was one from my, let's look. It's really like the patch I used last week, and this was also a little bit advanced with multiplexing and so on. Yes. The demo from that could be. I saw the demo also. That's and okay. My friends are also audio guys, and Axoloti could be a nice instrument to try out. And I tried it out. Okay, that was a little introduction about my bio. Okay, and now I will go into the Axoloti thing. I called the talk the portable vector machine because I think the portable thing is the most important thing about the Axoloti, that you can make your patch on the computer, load it on a microcontroller, a little thing, and then you can use it without hacking up a computer. I think the portable solution is very important, and this is the result. Because I have, you see there, my Axoloti and 50 kilos of other stuff around. Therefore, I don't know if it's really so important that it could be portable. But in fact, a simple performance could also be made only with an Axoloti and a display. But you know, you have to put all your things that you have on the table. What is this Axoloti? It's a microcontroller board developed by Johannes Tellmann, I think. He does it alone, and also the software, the hardware, he sells it. He has also a nice community board, and it's a one-man thing. Okay, you can buy it. It's already assembled. This is an Axoloti board. Someone would see it. It's the down part. The controller is something else to control the Axoloti, but it's not very expensive. It has a microcontroller. Hansi did me this. What is not so good? It's not so capable. I don't know. Really. And what it's important for us is the resolution. That's also not so much, but I'd have to say, for me, it could be doing good results for this. Okay, then this RAM, that's also a problem. I will talk later about it. And the onboard switching power supply. Okay, that is, you can also hook it up from the computer. Takes on the power supply, and the system will work. Okay, then we have this quarter stereo input jack and also the output jack. Also, that's not so fine for modular synthesis, but there we have. But you have DC coupled outputs, and that is very important. That's not so common. You have also headphone output, but that's not good. I tried it out. It's not separated outputs. It's the same output, but it's very noisy, and you can use it really only for the headphones. What's also nice about the board is you have a standard MIDI connection in and out, and that's very nice because you have to control it without. If you not use the computer, you have to control it. And a MIDI controller is the right way to do it. If you don't need a very high resolution, MIDI is not so good in this thing. All the stuff is on a micro SD card. Also, if you compile the patch, this goes on the micro SD card. Not really, but the other stuff goes there. And or in the internal RAM, SRAM. Okay, you can also hook up a controller with a USB controller, as a MIDI controller with the USB. That's also nice. You don't have to use the standard MIDI input or output. And okay, and what's very interesting? It's like an Arduino. You have different pins on it, where you have input and outputs, digital or analogs, where you can connect potentiometers, switches, and so on. And that's important if you need a fine control for something like frequency and so on. And you can design your own controller or buy something like this. That's very nice. You can solder this, and you have basic controls like potentiometers, switches, LEDs, and so on, and here a joystick also. And I use this for parameters. They should be very precise. Okay. Good. I will sit down. I will switch to the Axoloti, and you see it's already arrows. Okay, there is a software, a patch environment where you use the Axoloti, and when you connect it via USB, now it's connected. It should work. You have this console window where you see all the messages and the arrows, and you can connect it. And okay, USB device found, connected. Now the Axoloti is connected with the computer and the software. Then you have other windows where you can set up the patch, and you can do it so with a new patch, and you have an empty window. The main thing inside the patcher are these objects. Okay, that's a kind of little things that do something. Like an oscillator, you can do math with this, you can have a filter and so on. It's to say Axoloti is very, it's designed for music. Therefore you have, that's very nice, you have a little modular synthesizer inside this little box. I have also a relative big modular synthesizer setup, and I could say I can do all I do on the modular I can also do on the Axoloti, and that's that's a shame because I paid a lot for these things. But okay, okay, that's an object. And okay, that's an oscillator, I think. You have the pitch control, and you can connect here the chords and connect different objects together. You can also edit the definition. Okay, what is this? You won't see it anymore. Fuck. Okay. Okay, that's interesting. This object, we have two types of objects. The factory objects that programmed the designer, and there's also a really big, how you call it? Yes, a big community. They make their own things and objects, and this one are the interesting one because there are some guys they did some good objects for oscillographics and so on. But you can also, if you are able and program a little bit, modify other objects or create your own. And here you have different code inside. And you can modify this, make a copy, and make your own object if you know a little bit of programming. Okay. Other things, that's not so important. Other things you can do in an object is you can assign MIDIs, CCs on every control. That's very important because if you use a controller, you have to control it. Okay. Okay, I will switch back and take this something like this. Okay. What is important in Axoloti, and that's a little bit strange and not so nice, because if you are used to Euro-rack, you have only one connection and you put your Quartz in and it's okay. Here you have different types of connections of cables, and the very important one are the red ones. This S rate, you go in audio rate range, and then you have the blue one, K rate, and that's more for the modulation and voltage control for the models. And you have the yellow connections for gate signals and pulses and so on. Okay, then the green one for integers and then the pink connection for strings. You can also write things in. That's very important when you use it, because you can do some connections and also the objects have the colors. On the left side, these little circles are the inputs, and on the right side there are all the outputs. And if you have the color blue here, you can also put in a blue connection line, or connect a blue output to a blue input. And that's a little bit annoying, but there are also objects to convert from one type to another. Okay. Okay. One very important thing that not always is all aware about is the execution order of these objects. It's very important to know that the execution order is from left to right and from up to down. It's important where you place the object. That's not. Therefore, you will see my patches are very, very long and in the horizontal, and it's a little bit strange. Okay. Okay, and what's also interesting, you can do a patch, and that's have all other similar software like Pure Data or Max, and so you can do sub-patches. You can, because if you make a big patch, you don't really get it, and it will be very crowded, and you can make an object with other patches inside. Okay. Some questions. It's not a good tutorial, I know, but some question now.
We can.
Yes.
We can also knock things over. Yeah, we can do the questions in the microphone if there are any.
Mm-hmm. I don't.
Going once. Going twice.
Okay.
Continue.
I continue. Okay, we can do some patches. The first thing, I set a patch from 0. Okay, you have to have something to go out, a stereo out, and you type in out perhaps, and you have a stereo output. Okay, and then we have something to connect to the output. And what will we do? We will do a circle. Okay, that's a nice. And how we do a circle? We need a sine wave and another sine wave, a quadrature with another phase output. And the very interesting thing, you can do Ljubljana, okay, Ljubljana, and someone, the Sputnik, made already a Ljubljana object, and we need only one object for doing all this stuff. Okay, and we connect one x output and y output, and we go live. Live, it will compile it should be something there, and no, it's the brightness, because I don't talk up the Z input. Okay. Okay. And the nice thing about this object, we have the circle. That's the important thing. And Okay. And now you can also tweak the circle. Frequency. Okay, you see it. Frequency is going up and down. Okay. And you here see the limits of the axoloti, of the frequency range. But the very neat thing, you can also do this one and this one direct inside the object. I could also do this. Better? So, it's always better. Okay. You can move in the x-axis, in the y-axis, and also take up and down the radius of this of the Ljubljana object. Okay. And what will we do now? We need also we want to move this thing up and down and left and right, okay? We have this also on the Ljubljana, but it's important to know how to do it, how to do an offset, okay? And I already prepared something, I think, because it's not so nice to see me patching. Okay, and I will explain a little bit this very simple patch. If you want to move something, you have to add voltage in the right channel. If you want to move an object on left and right, you have to add or subtract voltages on the input. And we can do this with the mixer, okay? Okay. Here's a mixer. And we have the Ljubljana goes inside here, and we have this little knob here. Okay, this is a dial, and we can add voltage, and we mix it together. Okay. Super. Okay, but that's not what I want, because it's also. Don't look at it's growing. That's another part of the patch, okay? You see here, I have this dial here, who adds voltage to the circle. If I subtract it, it goes in the wrong end, and if you add it, it goes there, okay? You should see it also here. Okay, here I add voltage or subtract voltage. Okay, some questions about this? Too basic, I know. Okay. Then I would also show you how to do spiral. Okay, that's also a little thing that's nice. And if you want, that's one technique. If you want to do a spiral, you can modulate the amplitude of the signal. And you need a VCA for this, and I patched it here already. I show it you a little bit better. Here, here are VCA, okay, and they goes inside. I have always X channel and Y channel, X channel and Y channel, and this VCA is connected to a saw, and if I go up with the frequency, of the saw, the VCA always makes the shape bigger and taller and bigger and taller. And if you go up with the frequency, you have this impression that it will be a spiral. I try it now. Yes, it's very slow, and it should work. I don't know, because you see, and if you hit also the right spot, now it's not in sync, but you can have this nice spiral. Okay. Make a circle, make a spiral, make a smaller shape. Also, make a smaller or bigger shape. You do it like the spiral. You have to do this with a VCA, and but without the oscillator. If you go back here, you see it. I will zoom in a little bit. I go down now with the oscillator, and here it's the same. I connected the two VCAs to these controls because I want that the growing part is. I will disconnect this side, but it doesn't go down to 0. The saw. Okay, now we have a fixed. Okay, that's also not so good. I could do WVCA. Okay. The VCA makes grow the shape, and if you do the same amount of amplifying in also in the X and in the Y, the shape will grow symmetrically. Okay, move the shape. We already saw it with the offset. And I will show you also my performance parts that I think more interesting. And there we have also a little hack to display 3D objects from tables. And perhaps I could also show you this fancy hack, but someone interested to see how I do this. It's like taking from Ossi Studio, what's the software, use it for make all the calculation and then transform it to tables that you can use in Pure Data or in Axoloti to make this dispatch. Okay. This is not my patch, this is my performance patch. If you want, I can swap this, so could be nicer. Okay, I will try to clear. I have to explain, yes, simplest words. I don't explain how this patch works. I know it's a little bit difficult, I think, for someone who hasn't worked with it. But I go backwards for this thing. We have here. They could also turn on and swap another one. Okay, that's the result for now. Okay, I will explain exactly what this does. We have here this object is the Z output or input for the monitor. Within this patch, I can do also multiplexing two shapes with between two shapes to get rid of this connections line. I don't remember exactly how we call it, but love line, something like this. Oh. Okay. And that's important. This Axoloti is connected not with only the stereo cable, but also with the Z input. And you can do the Z axis modulation with this. Then we have here, that's all the patch on to do this multiplexing thing. I can explain it to you if you want. In reality, I have only switches. A switcher with a square wave that switches very fast to do two shapes, and with this delay I go down in the right moment and took down the brightness when this connection line should appear. Okay. Here, that's the output. No, that's not the output. It's here, left and right. See it? That was the same object we placed before. And that's not good with this. Perhaps I do a mix. Yes, it's better. Something better the key. Okay. But you see also the Vectrex direct. Okay. That's a little bit hypnotic now. This key. For you, I see the screen. Okay. What's going on here? We have two Ljubljana objects. They go inside this mixer. Okay. We have also a rotation patch, an XY rotation patch, where I can rotate all the shapes in the 3 axes. Now I will show you only one. Take off the multiplexing. Now I don't have multiplexing. I have only a mixer what's going on. And I can toggle on the rotation patch of this circle. Okay? Now the circle is rotating, and on the that's the set y-axis, and we are simulating a sphere. Okay? And we could do this also on another axis. So, and also on all 3 axes simultaneously. And you don't see nothing because it's too bright. Because I have also now okay, okay. Now it's going on very high frequency on all axes, and if you hit the right spot, you can also do some interesting things. Okay? I know I comprehend if you don't understand my patch, because it's a little bit complicated for someone who didn't made it. But okay, that's it. Okay, that was this rotation patch. I can also show you this rotation patch. That's very interesting for someone who knows mathematics. And there is a formula, you know it, and I can explain it really well. But how it's called, Derek, the formula, the rotation formula, Euler?
Yeah, rotation formula. I don't know the actual technical name for it. I've just always called it a rotator.
Okay. The 3 axis, okay. And with this formula, it's the same formula used in normal 3D graphics. You can, with this patch, you can rotate an object in different directions. I will now go down with the circular thing and show you the 3D object. Okay, that's like a cross. It's a little bit high with the frequency. Okay. Okay, this is a 3D object I mentioned before. I've tried to do this with hand in the first time. I had this idea to do this with these 3 tables, and for a pyramid I could do it by hand, and so okay, or a quadrant. It's better to connect first this point to the other point and then the other point. But in real, if you have more complex, that's not so complex, but if you have to calculate with which order you have to connect the different points to make a nice shape, you have the Chinese post man problem. Hansi, where are you? Okay, and Hansi had solved this problem. My postman had not solved it, and and I used the the software of Hansi to do this Ossi Studio to do this. Okay, I don't think it will handle it all, but if you put inside, hätte hier auch noch. Kann ich das einfach reinschmeißen? Nein, wenn ich... Okay. Ich kann ich ein Open machen? Okay. Was geht dann hier? Ist das das alte? Ah, it's good. Okay, now we have, I put into Ossi Studio OCB file, and we have now a square, and you see it here. Should work, but it doesn't. So. Okay. And the nice thing about Ossi Studio, all these informations about this point and this Vectrex are stored in a TXT file that Hansi, so you can hack it a little bit. And I show you how. Okay. Sorry? Too much?
No, turn it up louder.
Louder? Okay.
Louder and brighter.
Okay. Sorry for this presentation. It's fuck. Okay. I don't have to zoom it in. That's better. Okay, that's the cube inside the TXT file, and you have these lines and the vertices. So you need this information to fill the tables in the batch. And to extract this information and to fill this in the table in the tables inside the Axoloti patch. I made a little spreadsheet because that's I know because I work with spreadsheets, and you copy out these things in this spreadsheet. Also, you copy here in this yellow cell these lines. Okay, this one. And the vertices number in the other line here. It's then the magic happens. It were very complex calculations, and then there's an output. Okay, you have all the lines, all the points that you can copy then in the Axoloti object. I made here for pure data, and in Axoloti you have to write an array, and you can also copy this down and then put it in a table inside Axoloti. I show you now this thing. Okay. Here, this is the patch for the 3D thing. You have here underneath these three objects. These are tables, and you can edit it. And okay, and I copied the data you saw in the spreadsheet. I copied here in these tables. Okay, and we need three tables that for X, Y, and Z, Z or how it, I don't know. Okay, and you have this this object that reads the table, all three tables in with a precise frequency. And for this we have the phaser object. We saw it also in the presentation of the pure data library, and with this phaser you read all three of the tables. Okay, and that's the result of this patch. There's also the rotation patch that I showed you already, and if you have only the 3D patch, it would be fixed. But with the rotation patch, and you add the rotation patch to these forms, to these shapes, you can do these movements of basic shapes. You cannot do very complex shapes because the Axoloti will not have the precision to render it very well. Okay. So, I know it's a shitty presentation, but if you, yeah, it's really fun for you. Fine. Okay.
You're doing great, man.
Okay, but okay. If you have any question, I could also.
Yeah, we've got
you.
time for a couple of questions. Yeah,
Yes,
do you want to do the microphone, please, so we have it on the.
First, I just want to thank you for sharing all this stuff publicly, which you did, I think, right after you cracked the code for this hack. It was immediately online with directions for everything. So,
yes.
You know, again, thank you. It seems like a couple of years ago.
Yes. Yeah.
Yeah, it
1,
was very
2 years.
very generous to publish all this stuff. So thanks again. Will you decrease the frequency of the phaser that's reading the table so we can see what that looks like?
Yes. Okay, it's not live. Important thing that I not mentioned, you can, now I control the patch from the computer that's connected, but you can also do upload to SD card on startup, and you put up the patch on the microcontroller, and you are portable. Now I try it. It's more and more, and that's the minimum I could do with this setup. But I could also try it here. I don't know if I am on this way or on this shape or this shape. No, it's should do something, but I don't know if in the sub-patch that's the minimum I get now, and that's the maximum. Jonas? Yeah. Okay.
Yeah, I mean, imagine if it went slower, you would just start to see the dot tracing out the form, and
Yes,
it wouldn't resolve into a line.
But I think yes, here is it. Okay, wow. There are some more lines than needed, I think, because the other software doesn't work. Okay. I can do this tracing thing with this object also. And you see that's not really linear. And there's this spot. Okay.
I think we have time for one more question because we need some time for the artists for the evening to sound check. So, does anybody else have any burning desire? Here we go.
No, I just wanted to tell you, Roland, you seem to kind of apologize like for explaining some things over and over. But I think no matter how good some of us, not me, are in programming and understanding mathematics, it's always interesting to see other approaches, because it seems to me with vector techniques you can really go with basic, and even if you're very good at doing complicated things, it's always good to see the circle again and some really basic things that you can do with it, and remember like, aha, this also looks good, and you know, you can do all these complicated things and then see somebody else doing. I mean, Chris was very brave yesterday for doing performance only on this really simple circuit, and just showing that there is a lot of space, and I really liked your talk. Thank you very much.
No, thank you.
Thank you, Roland, for the presentation, the deep into the mind of the Axoloti. Thank you very much.